Hello, everyone. So this is our presentation about the secondary succession in Point Pleasant Park, Halifax, Nova Scotia, after the events of Hurricane Juan. Um, uh, Sorry, that was like a random transition. Before we get started, just a quick land acknowledgement and significance acknowledgement about Point Pleasant Park and where it's situated and its historical and traditional significance to the Mi'kmaq people. Its ancestral name is Amnitikati. Please forgive me if I'm saying that wrong. Which translates to spiritual place, as it used to be a very important spiritual gathering place for the Mi'kmaq people, and serves a lot of traditional value and is seen as very important. And they still, the Indigenous people of Nova Scotia still go to Point Pleasant Park, or Anitakati, regularly, and they host events, and they do traditional drumming and traditional dances and stuff there. They've even been doing reenactments or Indigenous retellings of Shakespeare plays in Point Pleasant Park, which is actually very interesting. Um, so it is still a place of great importance, and it's very important that we acknowledge that we are all treaty people, and this is a part of our history, and yeah. So a quick introduction on our research and sort of what exactly we're doing. So, in September of 2009, a Category 2 hurricane hit landfall in Halifax, Nova Scotia, and absolutely decimated Point Pleasant Park, and destroyed almost 85% of the trees there, and got rid of almost all the canopy and all the foliage. And it really did a number. It completely destroyed Point Pleasant Park. So, in the wake of this, it provided a very unique and useful opportunity for us to research secondary succession in the wake of a natural disaster, and how Point Pleasant Park as an ecosystem would rebound and return back from this destruction that occurred. So, this is important because it tells us a lot about how succession works in ecosystems, and how, like, the impacts and the functional effects that natural disasters and complete and utter destruction, like the kind of effects that it has on the ecosystem, on the forest, and on the vegetation there, which can provide us with insight about how, things may have looked in the past, or how things may have looked, however many years ago, based on what the data we can gather now, and observing how the vegetation and how the ecosystem rebounds after this sort of thing. There's been loads of studies all across the world, like in the Czech Republic and in hemlock spruce forest in Oregon. In our case, in Point Pleasant Park, we are in Acadian forest, so we have a lot of deciduous trees. So how the study has worked is we've essentially every single year since 2009, with the exception of 2020 due to COVID, we have gone out. There's 6 sites all scattered randomly across Point Pleasant Park, and they were randomly assigned, and they are yearly. They are people, undergrad students go, and we measure diameter at breast height of the trees in each site quadrant, tree density per species per site, along with the percent coverage of vegetation on the ground, to help us monitor and examine and sort of watch how the vegetation kind of returns and grows over the years.
The purpose of this study was to examine secondary succession in Point Pleasant Park by analyzing the changes over time from 6 different sites in the park. These sites were chosen because they were located in an area that were most affected by the park's past disturbances. At each site, data was collected from permanent plots. Within each plot, all tree species were identified, and the number of individuals and the diameter at breast height was recorded. Data was gathered from multiple samplings over years to evaluate how the forest has recovered over time. Community metrics such as species richness, tree density, basal area, and the Shannon Diversity Index were calculated to describe the changes over the years. Statistical analyses were then used to determine whether changes were significant. This experiment design allowed us to compare forest recovery across the 6 sites and helped us identify long-term trends in development. The Shannon Diversity Index results show that the overall forest community has increased significantly over time. The data across all 6 sites show that each site has become more diverse and even compared to earlier years. This increase shows a successional pattern where the community is slowly transitioning from a simple, low diverse community to a more complex community with more mixed species. Earlier, species such as white birch and poplar dominated, whereas now species such as red maple and balsam fir have begun to grow and dominate more over the time. As succession continues, the forest will likely soon reach its climax community, where it'll have stable species composition, high diversity, and a balanced dominance among species. While the rate of increase of the Shannon Diversity Index may slow as the species in the community reach an equilibrium, this doesn't mean the community will lose its high diversity or evenness. Overall, the uptrend in the Shannon Diversity Index shows that the forest at Point Pleasant Park is recovering successfully and is progressing towards a healthy and stable community.
So for question 2, which was how has the density of the dominant species in 2004 as well as the dominant species in 2024 changed over time? Why? What can you predict will happen to the dominant species as the forest moves towards its climax community, and why? So when we look at the density differences in the red spruce in 2004 and compared to 2024, we can see that there's actually been a little bit of a fluctuation between the two of them. However, we can see that this could in part be due to the fact that there are more sites that have been established. But we can see from the data that the regression line is poorly fit, meaning that the data is quite sporadic. And we can see, with this data, we can see that the different sites have a variety of different densities, which is most likely due to the fact of like seed dispersal, and just different, like being able to adapt and survive better in different areas of the park compared to others. But yeah, so we can see here that like there are some sites that fall way above the regression line and are way more have way higher density in comparison to other sites. And the reason for the increase of sites is most likely because of after Hurricane Juan, there was probably an increase in dispersal of seeds, and they probably went a lot further with their dispersal due to the high winds and extreme weather. And yeah, so what will most likely happen is, as we can see, like over here with 2025 and how things have changed, the populations and their densities will most likely remain somewhat stable over time, unless of course another natural disaster occurs. Because as we can see from 2004 up until like 2024 and 2025, we can see that like it's remained relatively stable, I suppose, with these, like, with two of the sites falling below the regression line and two sites falling above the regression line. Whereas here there was only 4 sites, but you get my drift. Um, but it's most likely that they'll sort of remain constant and reach like a plateau within their own respective territories, um, due to just reaching community equilibrium. Um, of course, unless, like I said, there was another natural disaster. But we can definitely see that there was an increase in seed dispersal post hurricane, which really broadened and made the range of the red spruce a lot larger. So, for our second dominant species, the red maple, one thing that we can actually observe is the fact that the linear regression line for it is almost the exact same as the one for the red spruce, which is actually very interesting, indicating that they both kind of have similar growth patterns and have kind of been have growing and have been affected sort of in the same sort of way and are responding in the same sort of way post hurricane. So one thing that is different about the two of them is when we look at the red maple, we can see that in 2004 their density was almost 0, meaning that they were extremely uncommon in Point Pleasant Park, and they were almost like unheard of, I guess. They were not present. Whereas in 2025, we can see that there is more sites that have way more red maples present in them, and they have kind of taken over and are very much more present in Point Pleasant Park. This is most likely due to the sort of introduction of red maples into Point Pleasant Park, most likely due to the extreme winds like provided by Hurricane Juan, sending the saplings most likely over into Point Pleasant Park, causing them to be planted and then causing like a huge uprising and providing that sort of means for an introduction of red maples into the Point Pleasant Park vegetation and ecosystem. With peak numbers actually reaching in 2019, before dipping back down again. This most likely indicates that the species is sort of probably like reaching a plateau again, and it will most likely remain stable, and probably won't increase it or decrease too much over the next few years. But yeah, so so it most likely will just plateau unless we have another instance where there's a lot of wind and more seed saplings are dispersed across the park, which could lead to a higher density again, or a peak density like we saw in 2019. But yeah, that's most likely the main reason why we saw this like increase in red maples post Hurricane Juan.
Hello, everybody. Welcome to my section of the discussion questions. I will be working on discussion question number 3. So, my question is, how has the species richness changed over time? Well, when looking at our class data, we can see that species richness has started quite low and then with a steady increase with some bumps in here, but we have a steady regression line overall. Now, from previous studies, like Turchin in 2016, they found that there was a significant increase in tree richness over the years, but there has been a minimum difference in ground flora richness, which is pretty interesting. So, this richness increase has mostly been due to the planting of over 70,000 Acadian trees in the park in 2008 by a group of volunteers, which we can see right here. We can see this jump here, and this has led to more growth of the forest and the species richness to increase tenfold. Now, what can we predict will happen to the species richness as the forest moves towards its climax community? The climax community, right here, you can see, right here, describes an ecosystem that has reached an equilibrium that can sustain itself for more generations without any external disturbances. So, we can predict that as the forest grows more and more, the richness will increase as more species are introduced to the community via tactics like seed dispersal or movement towards more resources, right? More nutrients. So the established community, these guys right here, intermediate species, will continue to grow and take up those resources, which causes more species richness in turn. And now we will be moving on to our conclusions portion. So we can conclude that Point Pleasant Park has seen a significant increase in species richness and the Shannon Diversity Index. Based on the trends in our data, we can predict that Point Pleasant Park is in the early to intermediate stage of succession and that the Acadian forest will continue to steadily diversify as it grows towards its climax community. It is also important to note that Point Pleasant Park is an urban park and that factor may affect the succession of the regenerating forest. So for one, urban parks are typically areas of high disturbance, which may impact nutrient uptake, seed dispersal, and growth rates. For two, Point Pleasant Park is especially vulnerable to natural disasters like hurricanes because of where it is located. The park extends to the eastmost point of the peninsula, facing the entrance to the harbor. This exposure to the greater harbor means that it is very susceptible to damage from storms, specifically wind and erosion. I would also like to note the Mi'kmaq practice of two-eyed seeing, which suggests that when we make decisions to improve scientific practices, that we also take into account the indigenous voices and knowledge, as well as your typical scientific process and perspective when making these decisions.